All right, so this is the last section of chapter 9, and we're going to look at weight and measure. Now, weight is the measure of the gravitational force that's pulled on an object, which is why a person that weighs a certain amount of weight on Earth weighs different on the moon. Okay, mass is the quantity of matter in an object. All right, so the quantity of the matter in the object is determined by molecular structure. That does not change. All right. The good thing is when we're going ahead and looking at the weight and measure here, we're looking at the metric system. The good thing about this is just because now we're talking about weight, all right, now we're just going ahead and not talk about meters. Now we're going to talk about grams. But the conversion works exactly the same as it does when we were talking about length, okay? So we're going to go ahead and just jump right in without revisiting the changing of units, although you could look at that on page 82. Okay, and I'm going to go and I'm going to convert 4.2 dgs or decigrams, okay, to milligrams. Okay, which means I'm going to go moving 2 units over. Okay, and decigrams are bigger. I'm going to milligrams, which means I'm going to multiply by powers of 10. Okay, so I have my 4.2, and I'm going to go ahead and I have to move my decimal over 2 places. Okay, and so I end up with 420 milligrams. Easy enough. Okay. And then if I want to take 620 centigrams and take that to grams, okay, now I'm moving from CG to grams, all right, and there's a DG in between, and I need to move over 2 units the other direction, which means I'm dividing by 10 twice, okay. So I have my 620. My decimal is at the end here, and I'm going to go ahead and move that over 2 places, 1, 2. And so I have 6.2. I can drop that ending 0 grams. Easy enough, all right? And I'll leave example 2 for you to work on. That's exactly the same as when we talked about lengths. So you should be just fine with this if you could go ahead and do lengths, all right? I'm going to go ahead and look at example 3 on here. And example 3, okay, is on 83 still, all right? And we're giving a table 9.10 that has cubics, okay, so volume and the weight of water, okay? So we're looking at an aquarium, holds 0.145 meters cubed of water. And I want to know what is the weight of that water. Okay, now we don't have anything here for meters cubed. Okay, actually we do. Okay, and 1 meter cubed is equal to 1 kiloliter, which weighs 1,000 kilograms. Okay, so we have 0.145, and that's meters cubed, which is 0.145 kiloliters. And I'm going to multiply that times 1,000. Which makes it bigger by 3 decimal places, so I have 145 kilograms. Done and done. Okay? So pretty easy, not too bad there. Just follow the charts. Look for if you have the unit you're starting off with in your chart, and look at the final result there. Okay? This step here, I could have skipped because they were exactly the same, but don't get used to always skipping. Okay, make sure that you're really looking at everything and making sure that you're getting to the right result. All right. Now we want to go ahead and we want to look at weight. Okay, and on page 84, okay, we have example 5, and it comes with its own chart. So I have 1 ounce is around 28 grams. 1 pound is 0.45 kilograms. Sorry, trying to mess with this again. It did something weird. And 1 ton, and tons abbreviated capital T, is abbreviated to 0.9 ton with an extra N and a T, which is a small t, so be really careful with these, okay? One's a capital T, one's a small t, so be really cautious, okay? And we're going to go ahead and work example 5, so I want to take 120 pounds, and I want to convert that to kilograms. Okay, so we're going to do the same thing we've been doing, 120 over 1, and it's pounds. And the conversion for kilograms for pounds is sorry about that. 0.45 kilograms to 1 pound. The pounds cancel, and so I have 120 multiplied by 0.45. Sorry, I'm running out of space here. And that equals 254 kilograms. Okay, so that's the first one. So we just go ahead, follow the same rules we've been doing. Okay, now if I go ahead to the next one, I'm going to make this bigger here. Okay, and I want to convert 500 grams to ounces. Okay, so going ahead and looking at my chart here, I have ounces. 1 ounce is around 28 grams. Okay, so I have 500 grams over 1. And I have 1 ounce is equal to 28 grams. My units cancel. So I got 500 divided by 28. Okay, which is around 17.85. Okay, they didn't tell us what to round it to, but usually these are 1 decimal places. So I'm going to call this 17.9 ounces. Okay, because remember when we have 5 after a number, the next number is 5 or higher, we add 1 to our tens place value. Okay, most of these are going to go ahead and be 1 decimal place answers. All right, I will go ahead and leave example 6 for you. All right, I'm going to do one more. I'm going to do example 7 before we go to temperature. Okay, so let's look at example 7, and that's on 85. All right, the prescribed dosage of a drug is 6 milligrams per kilogram of weight daily. I want to know how many 200 milligram tablets should be given to a patient who weighs 150 pounds. Okay, so we have to do a little bit of work for this one. Okay, first of all, I'm given that the weight of a person 1 pound is 0.45 kilograms. All right, so I'm going to go ahead and convert this person's weight to kilograms first, because I need the dosage is in terms of kilograms. So I need to transpose this person's weight. So I have a 150 pounds over 1, and I have 0.45 kilograms is equal to 1 pound. Okay, Go ahead and do the math for that. I end up with 67.5 kilograms. Okay, now I got to figure out the dosage per kilogram. Okay, so I have 67.5 kilograms, the weight of the person in kilograms, over 1. And then my dosage instructions are 6 milligrams per 1 kilogram. Okay, that's my dosage instructions. My units go ahead and cancel, and I have 67.5 times the 6 milligrams, all right, and I end up with 405 milligrams. Okay, now each tablet is 200 milligrams, so to divide this by 200, and I need the milligrams there. Okay, the units cancel out, and this person is going to need about 2.025 tablets. We're not going to obviously give them this little decimal of a tablet, so they're going to get 2 tablets as their dosage. Okay, and there's another example for you to try, example 8 on page 86. I'll see you back in a little bit here, and we're going to go ahead and cover temperature, and that's the end of chapter 9.